Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 3.5, 3D Simultaneous Equations. So 3D simultaneous equations are just like 2D simultaneous equations, except there are a bit more algebra involved, and it can be often solved by using Gaussian elimination, which is simply just elimination in a nutshell, as you might have learned during your GCSE years. Although it is often better to use matrices when you're trying to solve such equations, we haven't learned matrices yet, which I'm going to teach you in chapter 4. For now, we're going to look at the Gaussian elimination method, and I'm going to talk through the different geometries associated with the equations. So for the first one, I'm gonna give you something a bit more, a bit easier. So let's start with these three equations. Here they observe, like ones who are good at observing would see that these are on the left are all the same, so it's basically x plus y plus z, but they all equal to different numbers. For this, if we rearrange this such that it equals to the vector equations of a plane, then you should be able to get that the normal vector of all of them are 1, 1, 1s. Which means, since the normals are the same, they all are parallel to each other. So we have three parallel planes, as we have talked about last video, three parallel lines that never touches each other. These three symbolize the relative location to the origin. As we know, if we take the rearrange it such that this number is on the left and it equals to 0, then we can state that minus 5 is equal to minus d dot a, as we have talked about before. And this applies to all of them. So minus d dot a and 0 is also this. We can say in this sense that these are not, these values do not agree with each other, and so they contradict, and that also symbolizes a parallel. I think this might actually be a plus. No, it's minus, I think. Yeah, that would work. So with that said, this is the most general, the easiest case. It's unlikely they'll ask you this during the exam, so we'll go to the next one to see maybe a bit more applicable in the exam situations. Second one, it's kind of similar, but you can definitely tell again the first two are parallel because they have the same normal vector. So we have two lines that are two planes. Remember, these are planes that are parallel, with minus d plus a is 0 and minus 4 respectively. What about the next one? This is 3, 1 and 1 as the normal vector, and so it's not parallel, and so it has to be this case. There's only one other case for a set of two parallel lines. The third one can either be also parallel, or it can not be parallel, and in this case it's not. So technically there are two solutions here, and we can indeed find out the solution to these two vector lines. what we need to do is to do something called the Gaussian elimination, which means to remove some of these variables. For the purpose of two parallel lines, because these two are they do not agree, so we cannot use both of them at the same time. Rather, we need to use let's see, I'm gonna change red. We're gonna use this pair, and we are gonna use this pair. So we have two pairs of 3D solutions, which will give us a 1D solution, which is a variable of x, y, or z. Either would work. Depends on how you want to do things. Normally I state x as 1, but sometimes if it's a beautiful fraction, I'm gonna swap things, and I'm just you'll see what that means in a moment. So let's start with the red combo. If we take if we add the two together, we will get 4 lots of x take a y equals to 4, and with that we can equate that y equals to 4x take 4. That's all good. And now we have a value of a variable y. We can substitute in to get an xz equation, and then let's see, so if 3x plus 4x is 7x, add a y is there minus 4, that's only 1 minus 4 there, then we need to add the z equals to a 4, so that would give us 8 and 7x plus z, and we can now state that z in terms of x is 8 take 7x. So now we have y in terms of x, z in terms of x. We can state that x equals to 1, y is equal, this is technically speaking the equation line is x, x comma 4x take 4 comma and 8 take 7x. This will be the line factor in x in Cartesian form. You can swap this into vector form, but I'm not going to do that for now. With this, we can plug in numbers per se, because it's a particular line solution. Basically, if you sub in any value, you will get a particular dot on the vector line, and you will get a valid solution, because all lines are basically infinite number of dots. So if x is 1, we can state that y is 0 and z is 1. And so if you sub in x is 1, y is 0, z is 1, these two the first and the third equation would agree. That's the first part of the solution. Second part is to find the other dots. So one of them is blue, one of them is red, and it doesn't matter which one is which, because you can basically rotate this and it would swap places. It's not a big deal. You do not actually need to state with diagram to say that which line is which. You just need to write down the two line equations in this form. That is. So let's try the second half. We can do essentially the same thing, and that would give us 4x take y equals to 8, and we have y equals to 4x take 8. That's the first part. Then we want to find z. We sub in y, and we get 7x take 8 plus z equals to 4. And by rearranging, we can state that z is equal to 4 plus 8 is 12, take 7x. Same applies, sub in x, and write down the equation in factor form. X 4x take 8, 12 take 7x. They do bear resemblance because they are essentially parallel lines by definition. So if we state x is 1, then we can also tell that y, by substituting, is minus 4. Z, in other words, would be 12 take 7, give us a 5. So we've got another solution. You can sub in these two values into the equations above and find that they would fit our hypothesis, and that's a way of checking whether you've done something correct or not. Well, now we've talked through the two parallel line scenario. We no longer have parallel planes, and we now only have 3 non-parallel planes. So what do we do in this case? There are, once again, 3 different things that can happen. It can either have a sheaf formation, it can have a prism formation, or it can have a general solution kind of plane, basically single dot equation solution. So this one we cannot just tell, so we must calculate. So let's first find the intersection between these two planes. So x take z and x take y plus z, we can add both of them to 3. And let's mark our equations. So x, if we add them together, z cancels, x add to 2x's, take a y, give us 3, so y is 3 take 2x. And we have this, we can find z using this. So sub in y into the second part, get x take, so that would be a negative plus 2x minus 3, add z equals to 4. So that would give us a 7 take 3x is z. So I've got these two equations to bear in mind. So let us, let's use green. Kind of mark these two important relations. Now we want to try another set of 2, so we need to involve the third one just for completeness. Let's use these 2. So for this, we can try to cancel out there are multiple ways of doing this. I'm gonna leave things in terms of x just for demonstration purposes, but if you want to, you can cancel x. It might work better in this question in particular. So let's try. If I want to eliminate y, we need to double the first equation. So 2x's take 2y's add to z equals to 8. And with that, we can add both equations to minus 1. And we have 2x minus x is just x. 0 because this is negative of the 2y, and minus 3z add a to z give us minus z is minus 1. Hey, look, technically you can just stop here because I've realized that this means that the first equation is shown by using the two others, which means that in this scenario we have a solution in a line because they make sense, and there are no three solutions, there are only one solution. But the solution is in form of a line, and so it cannot be this case because this is a single dot. So given that the solution is a single line, it can only be a sheaf formation. For completeness sake, let's put these in terms of x. So we'll say that z is x plus 1. And with that, we can sub in this to find y. And if we do x plus z is 2x plus 1, take y equals to 4, and we get y is 2x take 3. So we find that it's this y and this y is negative of each other, and for the z, this is different. Let's see. So the negative case, it's just the normal direction. It's doesn't really matter because the plane, if you negative everything, then you essentially flip side, but it would still be the same equation. So that wouldn't make a difference. Let's see, so what happened here? Right, we've got x take z, and z is 1 plus x. Let's see. Unless I've done something wonky with the algebra here. I might have actually. Let's see. So this equation is supposed to be this equation substitute, and negative 3 take. Oh, actually, yes, this should be 2x take 3. This is just my algebra mistake. Yeah, I apologize for this. Take 3. This 3 goes away, and so this is essentially just x plus 3. And so this is wrong. This should be 1 take. Actually, this is minus. This is plus 2y, so y is negative here, so it's minus 2x. So it's minus x, so it's 1 plus x. Yes, indeed. Apologize for this algebra mess. Anyway, we have shown that both equations equal to the same line, and so it's a sheaf formation example. Next up, we're going to do the prism. Right, this video is ridiculously long. I might even chop it in half just for digestion purposes. But for now, let's keep going with doing the examples. This is the fourth one, and this will be the last one for this video. So you essentially do the same here. You try Gaussian elimination with two pairs. So let's start with the top two, and we will also do these two and see what happens. So in order to eliminate, let's try bottom take top. So we have minus 5x plus 0, and this is bottom take top, so this is plus 5 z equals to 10, which can simplify into 2 equals to z take x. So it's nice to do both things simultaneously along the way, such that you can see if there are things that will repeat itself in a certain way. So since we eliminated y, why don't we eliminate y as well here? So let's triple the top, the middle row, to minus 12x plus 3y plus 12z equals to 21, and we can use these two equations. Let's see, it would be ideal if we take 21 from take 2 from 21, so we have a 19 on the right. Then we take the y cancels, take 2, so that would be 10z, and on the left we have minus 12 take minus 2, give us minus 10x. So we have this equation, and if you don't actually need to even calculate anything, because you can just tell here z take x is 19 on 10, which is just shy of 2, which means that they are not the same equation, and so the solutions are more like in the form of this and that. They're close by but not quite. So this is again a line equation, and from this we can already tell without further working that this will have to be a sheaf formation, because this is the only other options with 3 planes not parallel while giving 2 lines solutions. And so we have a prism solution with 3 solutions of lines. For completeness sake, you can finish off finding the equation. I'm gonna leave it here because, to be honest, the algebra is relatively straightforward, and you can just kind of write down, rearrange, and as I've done in the sheaf formation, find the 3 lines, or 3 line equations on this particular solution type. So that would be the last example I'm going to do right here. For the unique solution, I'll cover during the matrices section, because that would make a lot more sense and it would be a lot easier to do. So there aren't much tips when it comes to doing Gaussian eliminations. Remember to eliminate one variable at a time if you need to. There are ways that you can do that can save you a bit of time, especially during my prism example. There was a way of eliminating x and z at the same time, because they are essentially negatives of each other, and they are meant to be very symmetrical because I made them up. But in general, try to eliminate your variable slowly and make sure you don't make algebraic mistakes. Also, inconsistent equation solutions will tell you a lot of information. Bear in mind, it's often not your mistake, it's just how the question was meant to be. So make sure, look at your solutions of the equations. They might not agree, and that would be fine. Just state your result geometrically in terms of sheaf, prism, and unique solutions. Right, I'm gonna give you two example questions to do, and I'm gonna ask you to find solutions in terms of vectors. So leave it in the terms of x, y, or z, and also tell me its geometry, like if it's sheaf, if it's prism, if it's three parallel lines, planes rather. So I'm gonna give you 5 seconds as usual, and I'm gonna show you the answer. So in 5, 4, 3, 2, 1. And there we go. The two solutions are respectively sheaf formation and prism formation. For the sheaf, there's only one equation in terms of x, is as shown as here. For the prism solution, there are 3 equations that you need to find, and you will be penalized if you don't write them down in like all 3 of them. So make sure you do write all the solutions down. Although the important thing to bear in mind is that you know the geometric interpretation, because that is easy marks often. With that said, this is it for this video. I hope you've learned something. If you have any questions regarding planes, let me know in the comment section below, and I will see you on my next one.